Imagine discovering a dinosaur so perfectly preserved that scientists could still see its skin, its armor, even the color it wore over 100 million years ago. Not a skeleton, not scattered bones packed loosely into rock. An almost complete animal, frozen mid-form, as though it had simply lain down to rest and never woken up. For most of the history of paleontology, dinosaurs have come to us as fragments, a femur here, a vertebra there, the ghost of a shape reconstructed from absence. We build them the way a detective builds a face from a handful of bones. Carefully, scientifically, but always with gaps. This is a story about the day those gaps closed. In 2011, deep inside an industrial mine in northern Alberta, a machine operator's blade struck something that shouldn't have existed. Not like this. Not after 110 million years. What came out of that rock would force scientists to rewrite what they thought they knew about armor, about camouflage, and about fear itself in the age of dinosaurs. So, what was buried in that mine? And why would a creature built like a living tank still need to hide? Northern Alberta is not a place people expect to find dinosaurs. It is a landscape of oil sands and heavy machinery, of excavators the size of houses tearing into ancient earth in search of bitumen, not bones. On March 21st, 2011, an equipment operator named Sean Funk was doing exactly that kind of work at Suncor's Millennium Mine, 30 kilometers north of Fort McMurray. His excavator bucket had cut through hundreds of layers of rock that day, the way it had every day before. Then the blade caught on something different, something with a texture that didn't belong. At first, it looked like nothing more than another lump of ancient rock, mottled and strange, hard in ways the surrounding sediment wasn't. Then someone noticed the pattern. Rows of raised, rounded shapes ran across its surface. Too symmetrical, too deliberate to be geology. Someone on site suspected fossilized wood, but the museum staff who arrived to inspect it saw something else entirely. The unmistakable architecture of armor. Word reached the Royal Tyrrell Museum of Paleontology in Drumheller, and paleontologists were dispatched to a mine that had no business producing one of the most important fossils of the century. What they found, still half encased in the block the excavator had torn loose, was the front 2/3 of an armored dinosaur, preserved not as bone, but as an entire animal, laid out in 3 dimensions, exactly as it had looked the day it died. Dr. Donald Henderson, curator of dinosaurs at the Royal Tyrrell Museum, would later describe the moment simply, "Finding an armored dinosaur that had drifted far out to sea was already remarkable. Finding it this well preserved was almost unbelievable." The mining crew had unearthed something that field paleontologists spend entire careers hoping to see even once. And this was only the beginning. To understand why this discovery mattered, you have to understand what most dinosaur fossils actually are. Bone survives. It's dense, mineral-rich, built to outlast the soft tissue around it. Skin does not survive, not usually. Muscle does not survive. The outer texture of an animal, the very thing that made it alive rather than a diagram, is almost always the first part to vanish, consumed by scavengers, broken down by bacteria, erased by time, long before fossilization even begins. This specimen broke that rule. Encased in its stone tomb was not a skeleton wearing the ghost of armor, but the armor itself, bony plates called osteoderms, still locked in the exact positions they occupied in life, running down the neck, across the shoulders, along the back in orderly rows. Draped over that armor was fossilized skin, preserved down to its texture, and covering many of the plates were remnants of keratin, the same tough structural protein that makes up fingernails, horns, and claws in animals today. In life, that keratin would have formed sheaths over the bony plates, making the animal's armor look even larger and sharper than the bone alone suggests. This level of preservation is called exceptional preservation, and paleontologists see it perhaps a handful of times in a generation. It typically requires a very specific, very unlikely sequence of events: rapid burial, low oxygen, and minerals that replace soft tissue before decay can erase it. Somewhere in the story of this animal's death, all of those conditions aligned. The result looks less like a fossil and more like a dinosaur that has simply been turned to stone mid-breath, sometimes described only half-jokingly as a dinosaur mummy. But a specimen this delicate does not simply lift out of the ground, ready for a museum floor. What came next would take years, and one man's extraordinary patience. As the massive rock slab containing the fossil was lifted from the mine, it fractured under its own weight, breaking into several large pieces. Museum staff worked quickly, wrapping and stabilizing each section in plaster before the long journey to the Royal Tyrrell Museum's preparation lab. There, the real work began. Technician Mark Mitchell was given the specimen, and what followed was not weeks, not months, but 6 years of work. Using fine tools under magnification, sometimes removing rock grain by grain, Mitchell painstakingly separated 110-million-year-old stone from the fragile tissue beneath it. A single mistake, a slip of the blade, could destroy detail that had survived unbroken since the Cretaceous. The skull alone took roughly 8 months to free. In total, Mitchell spent more than 7,000 hours on the specimen. Years of his working life devoted to revealing an animal that had been hidden from the world since before the Rocky Mountains existed in their current form. When the research team eventually published their formal description of the species in 2017, they gave it a name that paid tribute to that devotion: Borealopelta markmitchelli. Borealopelta, meaning northern shield. Markmitchelli, in honor of the technician whose patience made the entire discovery possible. Lead researcher Caleb Brown would later say plainly that without that commitment, the fossil might never have come to light at all. It is rare for a species name to belong not to the scientist who described it, but to the person who spent years quietly uncovering it, alone, under a lamp, with a small blade and an enormous amount of patience. And once Borealopelta finally emerged from the stone, it revealed something no one expected to find at all. Bone tells you shape. It rarely tells you color. For most of paleontology's history, the actual coloration of dinosaurs was pure speculation, informed guesswork, sometimes closer to art than science. Illustrators painted them in whatever palette felt dramatic: dull grays, deep greens, the muted tones of modern reptiles. Borealopelta changed that. Under microscopic analysis, researchers identified structures preserved within the fossilized skin called melanosomes, microscopic pigment-producing structures that, in living animals, determine coloration. Their shape and density can indicate not just that pigment existed, but roughly what color it produced. What the melanosomes revealed was a reddish-brown tone across the animal's back, fading to a paler shade along its underside. In the animal kingdom today, this pattern has a name: counter shading, It's the same camouflage strategy used by deer, by sharks, by countless other species. A gradient that flattens the appearance of an animal's body against light from above, making it harder for a predator or an observer to judge shape and distance at a glance. It is a stunning thing to look at a 110 million year old animal and know, not guess, what color it actually was. But it raised a question that would reshape how scientists thought about this animal's entire life. Why would an armored dinosaur need camouflage? Borealopelta was not small. Fully grown, it stretched roughly 18 feet long and weighed close to 3,000 pounds. A low, wide, heavily plated animal built like a fortress on 4 legs. Rows of bony armor ran across its back, and 2 long spines, potentially reaching up to 50 centimeters, projected from its shoulders, sheathed in keratin that would have made them look even more formidable in life. By every visible measure, this was an animal built to be left alone, and yet it was colored specifically to avoid being seen. Countershading only evolves under one kind of pressure: sustained predation. It is not a trait animals develop for no reason. It is a direct response to the risk of being hunted. For researchers, this was the discovery's most striking implication. Even a heavily armored, nearly 3,000-pound animal apparently still lived under real threat from Cretaceous predators large enough and dangerous enough to make hiding worthwhile. As Caleb Brown put it in the study's findings, strong predation pressure on an animal this massive and this armored says something chilling about just how dangerous the predators sharing its world must have been. Alberta, in the early Cretaceous, was home to large theropods capable of taking down prey far larger than themselves. Exactly which predator drove this evolutionary pressure isn't confirmed by the fossil itself. That remains an inference, not a certainty. But the message written into Borealopelta's skin is unmistakable. Even the tank-like giants of the Cretaceous world were prey to something. To understand that fear fully, we have to understand the world this animal actually lived in. Picture a coastal plain roughly 110 million years ago, somewhere in what is now western North America. Conifer forests stretch toward a shifting shoreline, their canopies dense enough to filter sunlight into scattered fragments on the forest floor. Ferns and cycads crowd the undergrowth. Rivers cut through the landscape on their way to the western interior seaway, a vast, shallow sea dividing the continent in 2. This was Borealopelta's world. Warm, humid, threaded with waterways, alive with green. Analysis of the animal's fossilized stomach contents, an almost unheard of find on its own, gives us a remarkably precise picture of how it fed. Rather than eating indiscriminately from the conifer-dominated landscape around it, Borealopelta was selective. The vast majority of its last meal was made up of ferns, alongside traces of charcoal and fragments of cycad material. That charcoal is telling. It suggests the animal was foraging in a recently burned landscape, drawn to the tender new fern growth that often sprouts first after a wildfire clears the forest floor. This was not a mindless grazer. It was a deliberate, selective herbivore, moving low and slow through a landscape shaped as much by fire and flood as by sunlight. Its body was built for exactly that kind of life. Low center of gravity, wide stance, armor angled to deflect an attack from above or the side. Not built for speed, built to endure. But even endurance has its limits, and on one particular day, in one particular season, something happened that neither armor nor camouflage could protect it from. How does an animal built like a fortress end up buried at the bottom of an ancient sea? The fossil itself holds the clue. Borealopelta wasn't found on land, and it wasn't found where it lived. It was discovered entombed in marine sediment, rock that formed on the floor of an ancient seaway, far from the forests and rivers that were its home. The leading hypothesis, based on the sediment surrounding the fossil and the animal's position, is this. Borealopelta likely died near a river, possibly during a flood event, and its carcass was swept downstream. Bloating from decomposition may have kept the body buoyant long enough to carry it out past the coastline and into open water, where it eventually lost buoyancy and sank back first to the seafloor. There, undisturbed by scavengers and rapidly covered by fine marine sediment, the conditions for exceptional preservation began. Minerals infiltrated the tissue before it could fully decay, gradually replacing skin, armor, and keratin with a stone record accurate down to the texture. Over millions of years, that sea floor became solid rock. And that rock eventually rose, shifted, and settled beneath what would become northern Alberta. It is worth being clear about something here. This account is not a certainty carved in stone. It is the most well-supported hypothesis based on where and how the animal was found. But a full and complete death record, a definitive final moment, is something science may never fully recover. What is certain is only this. An animal that lived its life avoiding predators on land ended up dying somewhere entirely unexpected, and that unexpected ending is precisely what preserved it well enough for us to find 110 million years later. Most dinosaur discoveries add a data point. Borealopelta added a dimension. Before this specimen, scientists understood ankylosaur and nodosaur armor largely through disconnected bones, plates found scattered, disassociated from the body, requiring guesswork to reconstruct their true arrangement and appearance. Borealopelta showed that armor in its actual living context. Exact positioning, keratin sheathing, spine length, texture, even shading. Before this specimen, dinosaur coloration was almost entirely speculative. Borealopelta offered direct physical evidence, not an artist's interpretation, but pigment structures that could be measured and analyzed. Before this specimen, the relationship between armored herbivores and their predators was inferred largely from anatomy and battle-scarred bones. Borealopelta offered something closer to a behavioral signature, written directly into the animal's own skin. Proof that fear and the evolutionary response to fear shaped even the most heavily defended animals of the Cretaceous. This is why paleontologists consistently describe it as one of the finest dinosaur fossils ever recovered. Not simply because of how complete it is, but because of how much it lets us understand about a world we can otherwise only reconstruct in fragments. For more than 100 million years, this animal waded beneath layers of rock, sediment, and shifting continents, entirely unaware that it would one day become one of the most important scientific discoveries of the modern age. It was not hunted for its bones. It was not sought out, searched for, or expected. It was simply struck by chance by a machine that had no idea what it had found. And in that single, ordinary moment in an industrial mine, an animal that lived and died in near total obscurity became something else entirely. A witness. A three-dimensional, full-color record of an age we can never visit. delivered to us with a clarity that skeletons alone could never provide. Somewhere in that ancient forest, this animal walked slowly beneath the conifers, ate ferns from a burned landscape, and carried, etched into its very skin, the memory of every predator it had ever needed to fear. It could not have known that its armor would fail to save it. It could not have known that the same flood that ended its life would be the very thing that preserved it, whole, for the next 110 million years. And it certainly could not have known that one day we would look into its skin and finally understand what it was like to be afraid, even while wearing armor built like stone.